Okay, here's our first one, log base 6 of x times y. So as soon as I see that those are multiplied, we can split that up with addition. So I can write this as log base 6 of x plus, and you have to keep the same base. So log base 6 of y. And yep, that's it. Pretty stinking easy, right? Let's try another one. Okay, look at this little beauty. I threw some numbers in here just so you can see what happens with numbers. It's the same thing as variables. So if I have log base 9 of 15 divided by 7, when you break that up, you are going to end up with log base 9 of 15 minus log base 9 of 7. Da-da-da-da-da-da. And it's truly that easy. This stuff is cool. Okay, check this one out. Log base 5 of the square root of p. Now on that last problem, what did we say? Anytime you see a radical, what do you need to do? Change it to an exponent, so let's do that right now. This is actually log base 5 of p to what power? 1/2. And what is the word we just used? The power? So if I'm looking at this power here, I'm going to take p to the 1/2. I'm going to take this 1/2 here and bring it in front. So I actually have 1/2 p, 1/2 log base 5 of p. That's it. You just bring the power in front so you no longer have that exponent you're trying to deal with. You can bring it in front and work with it. Logarithmic properties. Now, one thing that I will say I haven't said so far, and I should have, so here it goes now. Make sure whenever you're writing out your logs that the log is on the same line and your base is below it. The log and the number is on the same line, your base is below it. Log and the number, the 1/2's a coefficient, and your base is below it. So that is how you write a logarithm. This is not the same thing. Log 5p, that's different. All right, we'll talk about that this next time, what a common log is, but that is different. You have to make sure that this 5 is a subscript, and then that is how you work with logarithms. Cool. Let's try some that are a bit, kick it up a notch. All right, check out this little beauty. We have log base a of this whole thing, mnq divided by p squared t to the 4th. So we put everything together. We've got multiplication, so we're using the product property. We've got a quotient, so we're using division, their quotient property. And we have powers, so we get to use our power property. Pretty cool, right? When you go to solve these problems, you start with what is encompassing everything. So what's my biggie here? What touches everything? What operation? Division. So start there. So I'm really going to look at this and say, okay, log base a of my numerator, which is mnq, minus log base a of my p squared t to the 4th. Now you have a separate problem. Whenever you go through at this point, work your first, or this whole deal on the left and the whole deal here on the right. So let's do it. What is happening here? mn and q, what operation is being done? Multiplication. So let's use the product property, shall we? So if I'm using the product property, what do we do with the m, the n, and the q? Add it up. Let's do it right now. You have log base a of m plus log base a of n plus log base a of q. When we say we're going to expand this thing, that is exactly what we're doing. Cool. Now, let's look at our next side over here. On the right, we have this whole piece. Now, I'm going to be subtracting all of that, so I'm going to use blue just so that you can see the difference here. But I am multiplying a p squared times a t to the 4th. So when I break that up, I have log base a of p squared plus log base a of t to the fourth. Cool. Are we finished? No. With this red side over here on the left, that one's taken care of. But what's the problem with the blue? Ooh, we got an exponent. Can you have an exponent in your final answer with logarithms? No, you may not. Good job. Okay, so let's rewrite this. And what do we do with those exponents? Bring it in front. Good for you. You got this thing. So let's write it out. I'm going to bring that in front, and at the same time, I'm going to go ahead and distribute my negative sign to both terms. So we're going to do a whole lot here in one step. Ask me if you have any questions in class, because I want to make sure you get this. So for that front part, we still just have log base a of m plus log base a of n plus log base a of q minus a 2 log base a of p minus, because remember we're distributing, a 4 log base a of t. And that, ladies and gentlemen, is our final answer. And a Mondo Mega point that I want to bring up to you right now is the fact that you have a double minus sign. Anything that has a minus sign goes in the denominator. All right? And you'll practice that. Now, for a lot of these problems in your My Math Lab homework, they are multiple choice. But you have got to be showing your work on your paper before you can get credit. And it says that on your test. You have to show work to get credit, so make sure you are doing that. And this is what I talk about. So you have to show all the steps of where you're breaking everything down in order to get credit for that. I don't want you to just be able to pick a multiple choice problem and get lucky. I want to make sure that you understand what it is that you're doing. All right? Cool. Okay, we've expanded some. Now let's condense these. My opinion, the condensing is way easier. You just go through and label everything it is that you're doing. Now here I have a log base 3 of x plus 2, so that whole thing goes together. But what about this plus sign? Now I have a log base 3, and a log base 3. So in between those different logs, I want to see what's happening, and I'm going to use a different color here. There's a plus sign and there's a minus sign between logarithms. So what does the plus sign between logarithms represent? Multiplication. What does the minus sign between logarithms represent? Division, because that's our quotient rule. So let's do that thing. Notice this x plus 2 up here in the front is just part of my log base 3. Remember, there is no sum property at all. No property, no rule that deals with sums. So you have to leave that alone. But you are going to multiply log base 3. This x and this x plus 2 get multiplied. Then you have this division here, so you take the two things that are multiplied and you divide it by a 2. The kicker to these problems is when it's all said and done, you have a single logarithm. Where I see people mess up the most on these problems is you want to do log base 3 of x times x plus 2 divided by log base 3 of 2, and that is majorly wrong. Bad news bears right there. No, no, no. When you're looking at those problems, you want a single logarithm in your final answer. So you just have your single logarithm up front that goes with your problem of x times x plus 2 divided by 2. Now, if you want, you can distribute this x, but you don't have to. I don't think I probably would, just because you can leave it like this and it's no problem. Okay, let's try another one. Okay, let's take a look at this thing. If I have 2 log base a of m minus 3 log base a of n, then you can look back through these problems and say, okay, what are the different properties I have and what does it look like? So let's start moving this stuff around. This 2, anytime you have a 2 in front, you know that's an exponent. My 3 in front here, also an exponent. What's that minus sign between them represent? Division, that's right. So I know I'm using my quotient property for my division. So the beauty of these kinds of problems is you can go directly to the answer all in one step. So log base a of m squared divided by n cubed. And that is why I think condensing is so much easier. Pretty sweet. Let's try one more. Okay, now check this out. I have 2 minus signs in this problem. Now, what did we say on one of those last problems when you have 2 minus signs? What does that mean? Yep, both are in the denominator. That does not mean that you have 2 divisions on that. Just means that both of those things are in the denominator. So technically what we have is 5 log base a of x minus parenthesis log base a of y plus 4 log base a of z. So the plus sign here tells me that these are multiplied, but they're both in the denominator to be multiplied in the denominator. That's all that really means. So I have this as division, this as multiply, and now let's put both of those things together. Gave myself just a little bit more room there by squishing it up. So I'm going to take this 5 and move it in the exponent. I'm going to take this 4, move it in the exponent. So I actually have log base a, so a big log base a because they're all base a's. Then I know the top of my fraction is an x, and the bottom is my y, z to the 4th. And that is our answer. So I have multiplied in the bottom that y and that z to the 4th, and in the numerator, because that's the only thing that's in front of the subtraction sign here, so I know this is numerator in front, denominator is behind. Not too bad, right? You got this. Good luck on your homework.